Hello everyone and welcome to Handmade Heroes, show where we code a complete game live on stream. I am taking the steps last weekend and this weekend to basically give us a more, how should I put it, a more modder friendly file format. The reason for this is we were doing, we decided to allow sort of more integrated artwork and art pipeline stuff in the game just because we have the opportunity to use that now. And so while I was in there, I just decided let's make sure that this stuff can be used to trade asset files and stuff like that in some way that'll actually be useful. And so I think that's really all we're doing right now. We mostly finished the other stuff, which was getting the PNG, like being able to update art assets in real time using the PNG. That stuff we did okay. And so now what we're doing is just kind of like settling in on a file format that has some additional information in it so that not only can we maybe use this file format to help with the art asset reloading, just to make it a little cleaner, but this will also allow us potentially to like let people do more with these files than I was originally anticipating we would allow people to do with Handmade Hero when it comes out. So if we go ahead and take a look at what we were in the middle of doing, you know, we kept the code compiling in cleanly and all that, so we actually are still running on the old file format v0, but we made a new file format v1 that was in there. And so, you know, if you run the game, it's still exactly the same as it was. It still can load its old assets and all that stuff. So that's good, but we're now taking a look at making it so that we can do a conversion to a new file format, and also basically do that anytime we want to. And also we want to make it so that we can sort of have, maybe hopefully this will be like sort of the last file format. Hopefully we won't have to do much more to it. Maybe we make some slight tweaks, but I don't really want to have to fuss with the file format very often, obviously. So looking at what we used to have, you can see we had here like three things that got changed. And so this was the old file format. We've got the new file format kind of documented here. Here's the header. We added some reserved stuff in there just in case we want to add some new arrays. We won't have to break the file format going forwards to add some new arrays, so on. And then we added this annotation stuff. The point of the annotation stuff is just now we would be able to store information about where assets came from, which will make it easier to hot reload them. And it also make it easier for people when they trade files to know what assets they have and where they came from if they want to, you know. So that seems good. The last thing I think I want to do is take the HHA asset struct. And we have a couple of choices here. One of the choices we have is to make this HHA asset struct a little bit more verbose. So actually put in there what kind of data everything is and so on. The other choice we have is to add that to the annotation. I think I want to put it in here. And the reason I want to put it in here is I think I want to say, look, let's just, since we're going to make this a more flexible file format, let's just go ahead, waste a little space, but let's, with every single asset, let's say explicitly where it is in the file, how big it is, and what type it is. So that any individual HHA asset can, even if you have no idea what you're looking at, right? Like you have no idea if it's a bitmap or a sound or a font, or maybe you don't even know what fonts are. Like you're just a utility that's operating on an HHA file. You have no idea how to read those. Something that still allows you to effectively edit the file. So basically what we're doing here is we're putting in information that you wouldn't actually need if you knew probably what you were doing, but to make it easier to write utilities that don't have to know everything, right? This also makes us a little more future-proof. It means that if we have an HHA editor that allows you to like move assets around, like let's say you make a thing called HHA merge, and it allows you to like, maybe it show, like let's say someone community makes HHA merge. It's a thing that loads two HHA files and allows you to pick which assets you want from each, and then writes a third file out that has just those the combination of those two assets, right? Well, that utility would have to understand a bunch of stuff in order to do that right now. Why? Because all we store in the HHA asset is the offset to the data. In order to know how big the data is so that you can move it from one file to another and copy it, right? You have to first know the type and then look at the actual type information, the actual struct information here to figure out how big it should be. Because in order to move a bitmap, you have to come in here and read the dimensions of the bitmap, because the definition of a bitmap is 32-bit integers that are as many as the dim0 times the dim1. So without knowing it's a bitmap and reading out the dimensions from the bitmap, you can't actually move the data associated with the asset, right? So you can see why this is a particularly annoying thing, right? So what I would rather do here is I would rather regularize this and say, okay, we're going to be a little more upstanding citizen here. The original file format was just made for our simplistic purposes. Let's be a little bit better about that. Make something a little more robust and editable, you know, because we're looking past just shipping file format to moddable file format almost. And the things you want to do there become, you want to waste a little space and get back some flexibility. Those are, you know, things you might want to do. And it's not even really about wasting space. You know, I wasn't super concerned about space originally or anything. It's just you don't spend a lot of time putting in features that you don't need, right? These are features we don't need, but now we kind of want to have them so that going forwards we can use them, right? So, you know, we need them now, or want them, let's say. So what I would like to do with the HHA asset is say, okay, let's say that there's the v0 version of the HHA asset, like so, right? Here's that v0 version. And now the new version of this will actually have additional information. It'll have a data size, and the data size will say, okay, if I go to this offset, how much do I need to read? And then it will also have at the end of this a data type, right? And that'll tell us whether it's a bitmap, a sound, or a font, or anything else we might want to add, right? So now there's an enum HHA asset type, and in here we'll just say bitmap. I might put an unknown or none, something where we just basically say, like, look, there's nothing here yet. I often put that as the 0 element so that if I want to have an uninitialized one, I can, and I can test for it. But right now we just have bitmaps, sounds, and fonts. That's what we've got. And so that's what we're going to say. So now what I want to do is I want to have it so that I can come in here and I can specify the data type and the data size for every asset. So now if someone wants to move an asset from one file to another, they don't need to know anything about it. They just need to know that they're going to move this much data and then whatever's in here. Now, in order to make this also, again, a little bit more flexible, I want to make sure that the amount of storage that goes on here is a little bit more predictable as well. So you can see we've got a bunch of things. We've got like a sound and a bitmap and a font, and they're a certain size. So I want to still maintain that flat structure so they can just be copied around. But I'm going to actually put in this union here a thing that says the maximum size we ever expect everything to be, right? Like maybe we call this, you know, max union size or something, right? And what we could do is set that to something that we think is reasonable, like something that, oh, right, I'm not supposed to use a calculator anymore. There we go. What I want to do is set that union size to something that I can actually anticipate being a reasonable block size to ever move around. So I've got the bitmaps, the bitmap, the sound, and the font. Yeah, if you look at how big those are right now, right, you can see that they're not particularly large. It looks like we've got 5 32-bit integers here, 3 here, and 4 here, right? So if we said something like this, that would be far bigger than anything we have right now and plenty of room for anything that we might need. And so if I go in and see how big that would be, let's suppose we have 10,000 assets. seems, maybe let's go even larger than that. Let's say we have a bunch of fonts, like 60,000 assets, right? And then we want to see how big the asset load would be for each of those. Let's actually go, let's make this, since this is 1, 2, 3 of those, let's actually make this so that they all line up, right? So we have 1, 2, 3, 16. So we have 16 total U64s, which is 16 times 8, right? So that would be 7 megabytes for the asset store. That's not even in the realm of problematic considerations for us. So that's totally fine. I could even bump this a little bit more if we wanted to. I'm just not sure we really need to. Assets don't really need much information because the bulk of their data goes into the flexible data store. This is only the part that is stored for use in the actual processing of the game. So I just don't anticipate it ever needing to be particularly large, right? So one thing we can do here, I don't know that we ever did a CT assert. Oops. Yeah, we didn't. So one thing that might be nice to do is to assert that this thing never changes size, right? And that's something that you'd like to do in all of these. You'd like to assert that none of these things change size. So you typically you pick what the size of them should be, and then you just assert that they can't ever be a different size than that, right? And so typically what you do is you have something that's like a compile time assert, and you say like, okay, you know, let's compile time assert here. Let's compile time assert that, you know, the size of an HHA asset is the same as what I just said it should be, 16, you know, 8 byte entries, right? I mean, I guess I could just multiply 16 by 8 and put it in there, but I decided not to do that for reasons we're not quite sure why. So if we, you know, want to do that, we could also make these be more cache aligned, I suppose, by, well, you know, it doesn't really matter because we're only going to touch the first part of them anyway, so they'll generally be, that first 64 bytes will generally be in there, so keeping the padding won't actually matter, so I think that's fine. So there's these compile time asserts are a thing that we'd want to say, look, I just want you to assert this at compile time. And the way that you do this in modern C++ is they actually have one, but you can actually create one from, from like, by using like tricks, right? You can actually create your own compile time assert if the compiler doesn't have one. And the compiler never did have one, like back before 2012 or 2013 or whatever. There was no such thing as a compile time assert built into the language, so you couldn't do something like say, I require this to actually be true. So what you had to do was you had to figure out some way of triggering an assertion where the compiler would fail in the case where the thing wasn't true, right? And so let's suppose we want to do something like that. Let me take this out for a second here. And we'll just try to reverse engineer how to make something like that. So let's suppose I wanted to declare like a global variable or something like this that just never gets used, right? So let's suppose I wanted to do something like, you know, global variable, foo. Let's suppose I did that, right? What you can see here is oops, do that one more time, right? What? Is that better? There we go. So let's suppose that I wanted to create one of these things here, right? Well, if I created something of size 1, it would work. If I created something of size 0, it wouldn't work, right? So if I wanted to generate a compile time error based off of some expression, well, what I could do is I could say, look, what if I just took some expression that I could evaluate at compile time, and then made what I declared this variable to be based on that. So if it's equal the way I want it to be, I'll evaluate to 1, which will work. If it's not equal, I'll evaluate to 0, right? So what you can see here is that this worked because it is equal to that size. If I change it, right, so now I say, oh yeah, and by the way, there's like an int at the end of this thing, you can see that now it will error. Make sense? So, you know, this isn't probably not a particularly great way to do compiler time of search, just the first thing that came to mind. So I just wanted to show you how to make it whole cloth. You could probably look up better ways to do it. On the internet, there's probably people who have like thought about the cleanest way to make a compile time assert if your compiler doesn't support it. But that's an obvious way to do it, right? You say ct assert, right? Let's say I want to make this macro now. I want that to work. I say, okay, ct work, here's my expression that I want to be true. I just basically do this, right? Where I say, okay, I've got an integer array foo, and I want this expression to be true. So whatever the expression is, I want it to be true, and then I'll do this thing, and off it'll go, right? Now, of course, one problem that I'll get if I actually do this is that when I actually run the, like this will work, oops. So if I do this, it'll work, but, and you know, it errors out as it should. One problem is that as soon as I go to make a second one, so let's say I wanted to make sure also that HHA annotation was always the same size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why are there 11? Oh, there it is, 12. 12, I don't know why we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 for some reason. That doesn't seem like a good number. I feel like 16. Everyone likes powers of 2 better. So if it's 12, I would want to add 4 to that. So we'll just say that. So there's the annotation struct. So I want that one to be 16 large. Oops. So these are both the same size now. And the problem that we get, as you can see here, is I'm trying to assert on 2 different things, but the problem is that since I gave this thing a name, it's going to conflict, right? These are both going to try to talk about something called foo, and that is going to make it so that I can't have more than one compile time assert. Now, one thing that people will often do to fix that is they'll say like, oh, okay, you just pass in a name, right? And that'll work, but it's a little annoying because we'd rather just have it work without the name, right? So what we would rather do here is have something that we can define in some way that, you know, doesn't have that problem, right? So some way that we can generate a name here that we know will be unique, right? And so we've done stuff like this before. What we would like to do here is maybe use the paste operator, right? And stick a counter in there or a line number, for example. And when we do that, this would work just fine if it weren't for the fact that the paste operator is defined as not evaluating this value until after the paste. So this will actually stick __ line, just the actual words, right? Which isn't, I wanted it to use the line number and it's not doing that, right? So what we'd rather do here is have some way of this actually using the line number or something or a counter or anything like that to actually get us a differing value here. And so what we want to do is use that weird trick where we keep calling down until we get enough deep to make it actually have evaluated the line and turned it into a number, right? So if I do this, In theory, I should be able to make this happen, except that actually has to be the value. So now it will actually turn it into a number. So the first one down will pass this into here. The second one will turn it into a number and pass it here. And then the final one will paste a number on the end. The C macro thing is not great. I admit that. I believe you can't do it just this way. Because the first time in it, it just passes the word line. It's just a disaster. It's a bad macro language. What can you say? However, this will work. And so what I can do here is make a little like CT assert. So no one will ever accidentally use this name. And now we're good to go. There's one sort of annoyance here. And what that is that, well, okay, so we've got this thing. And now what we're doing in a lot of cases is we're, declaring something that looks like that. Well, that's actually a data member. And, probably the compiler will get rid of it. But who's to say? Some compilers like GCC are really bad with static data members, or global data members, rather. I remember there were versions of GCC that if you ever had a switch statement that could have looked at a value in the data segment, then it never got rid of anything in the data set. There was some really ridiculous stuff. I remember crazy stuff in GCC that would keep it from ever removing data segment stuff. So, do we care that much? No, not really. But is there an easier way for us to do this? Well, this is the thing that we need to have error out, right? So the question is, could we just turn this into something else, like a function declaration or something that wouldn't actually, cause a problem? Like, could we just say, oh, can we just throw it into a struct, right? And see if that causes a problem, right? Well, the first thing you can see here is it's warning us because we have a symbol that can never be used, right? And, maybe we could just move the name outside it and do that, and we'd be good, Looks pretty good. So that's a little better. If I zeroed it, I will get the non-standard extension error. I don't know. Will this give me a better error? No, it's still a non-standard zero. It's still a non-standard. I want a harder error than that. Trying to think if I can get a harder error than that. Well, you know what? This is okay. That's an error we want. So let's see. That compiles, that doesn't. So that's really all I need for my compile time assert. So I'm going to go ahead and just grab that. I'm going to put it in here. And we'll go from there. So here's my struct name. Right? Here's my brackets expression. Oops. Put that in there. And off I go. So now I should be able to just loft this up into our platform library that everyone can use, where the standard assert is. And, here we've got sort of our debug stuff. I can go ahead and drop this in. It's completely, it doesn't need to be compiled out ever. It can be always compiled in because it doesn't actually do anything. So it's just purely compile time checking. So at that point, this is just, we're good to go. So what I can do here is I can place these anytime we've got one of these. I can just place these, and we're saying we need these to be specific sizes because from now on, we're going to expect them to be locked in place, right? So I can just kind of step in here and say, okay, each of these things is, going to be a particular size. If anyone changes it, they need to make sure that they understand that we actually load these and operate on them directly, so please don't fuss with them, and off we go. So this is 1, 2, 3, 4, so that's for 16 of those. So that is 16 4-byte values, plus 1, 2, 3, plus 8 8-byte values. Let's compile this. There we go. And now if we touch anything, we should get errors immediately, and that's good. Oops. And that's all we needed. So that's all we needed. So now we've got our file format laid out the way that we want it. Looks like I already had the asset data type ID stuff. I had already started on that. I'm going to leave that as HHA asset type. I think I like that phrasing better. So we'll just go eliminate that. And I'm going to get rid of that. So now we're just left with these. I don't know what font type was meant to do exactly. I guess that was just this for picking fonts. I guess that was just for picking fonts. Who knows? So anyway, looking through here, we now have, I think, everything that I actually wanted us to have is now specified relatively cleanly. I can move this up to the top. That's the data type there. I want to do one more thing, in it, kind of like the CT assert there that we've got. I want to do one more thing. The thing that I would like to do is make a way for us to specify which type we were referring to as kind of a bit of documentation, if you will. So the way that I like to do this is, right, I mean, let me just give an example. So what I would like to do is here's the data type. I'd rather it be that. But the problem is that until very recently, C and C++ didn't have a way of saying this enum is a U32. So I want it to be 32 bits. The compiler was free to make it 8 bits or 16 bits or however many bits it wanted. It didn't have to do any particular size. But I want it to be this size. But I would also like to notate to the people who may be reading this that it comes from a particular place. So I just usually do a thing where I pound define enum32 and flag 32 to basically have a type that is ignored. So they both evaluate to, you know, a 32, a U32 as if they were a type, but they allow me to just stick a little data in there. So for example, I can say enum32, this is supposed to be an HHA asset type, right? And this is the data type, right? And I could just say type, right, in a sense, because that's what it is. It's just the type of the asset, okay? And similarly, anywhere else that I had a flag like that, I can have that. So this right here, you know, we had to notate it like this before. I can make that a little cleaner by just saying, okay, HHH sound chain. There we go. So now you know, well, it's a 32-bit number, but it actually said it's just one of these is all it's actually trying to tell you. So that's kind of a nice way to do that. And then similarly, like with the tag up here, same thing. This is an ID. It's an HHA tag ID. Or what is it called? Asset tag ID. Like so. And so now everything is kind of properly marked up with, you know, what it's supposed to have. And it's easier, maybe a little bit easier for people to know what that's supposed to be. I tend to like that. If you don't like it, no biggie. You know, it's not a thing I think is particularly important. It's just something I tend to like to do. It makes things a little bit nicer to read. All right, so that's the final file format that I think we want to go with right now. And so what I would like to do is now I would like to just finish the importer thing, right? And so once we so that we can import everything, into the new file format from the old file format, so we can still run all of our old stuff exactly the way that we used to, just as a proof of concept. And then from then on, we can just focus on importing new stuff and how that's going to work. I think that's really all we need to do. Now, looking at these things, there's a couple there's one more thing that might be arguably a good idea. So if we look at the values not sure how to state this properly. So one of the things that we want to think about is how are we going to quickly access these assets? And when we're doing something like the asset matching, we have a lot of ways we might be able to accelerate the lookups. For example, we know that for something like the head, there might be two things, like the expression that, is it smiling, is it whatever? And then the facing direction, right? Which direction is it going? And one of the things that we would know about those is we always know that there's only a certain lookup. Like, we know there's only 4 facing directions or something, right? So we could think of trying to do things that allow us to access those more quickly. The problem with that is it starts to cut down on our ability to make changes to those, like maybe eventually we want 8 facing directions or 16 facing directions. Having a floating point value means you can always subdivide your range pretty much forever, because you're never going to really hit that 24-bit limit. So it's hard to say. So I'm tempted to do something like that, but I'm just going to say, look, we'll just deal with it on the back end. That's something we'll just have to write optimized lookups for. And let's just leave it as a floating point arbitrary bag of crap. And we'll just deal with it after the fact, because that is the thing that would let us have the most expressive file format. And that's sort of what we're doing here, is letting that happen. All right. So now what I want to do is I want to make a thing. If we pop over to the HHA editor, I want to make a thing that allows us to load in an asset, get all the information that we need out of it, and then be able to write it to a new HHA. And that's all I'm going to try and do today, is get that basic stuff going. Now, the annotations got a little more complicated since we first typed that in. So let's make sure we get them all in there, right? So here's our loaded HHA annotation. And what we want is all of these things, right? This all should be in there. So we want the source file date and the checksum. The source file base name offset is not a thing we need, because that's just actually going to become a pointer, right? So that's the source file base name down here. The asset name and description and author, all the same, right? We should also put those reserved in here, I suppose, because we want to carry them through, so we'll keep those in there. We have the source file base name count, the asset name count, description count, author count. Those are all implicitly caught in here, so we don't need those. Then we've got sprite sheet XY and the reserved, those we do need. So this is the data that comes from the file. This is the data that is loaded out of the file, like so. And really, these are counted strings. This is basically like the buffer stuff. What was that we had here? That was really the buffer. I don't remember where we defined that stuff, to be honest. It's in shared. So I really want to use a string here. Like I said, I feel like that's the best way to do things typically, so I probably just want that. Like so, and we'll make sure that's defined somewhere, right? That's in what, shared? Okay. So I would like there to be easy ways to define these things. So let's go ahead and make some of those. Inside Handmade shared, I don't know if we already have one, but specifically what I would want here is a way to define a constant string. I don't think we ever did one of those, but basically a way to define a string in a convenient way. So if we wanted to do something like that, I'm just going to call it wrapped z, and basically all this is going to do is it'll take, and it probably needs to be, we have a string length somewhere, right? Yeah, it looks like we've got that, so it looks like it's external anyway. So what I want to do is say, okay, if you're going to take a string and you want to produce one of our sort of counted strings from the kind that C unfortunately defaults to, this is our Z string here, then what we could do is just say, all right, let's convert that. It's going to be, the count is going to be the string length of Z, and then the result data is just going to be the pointer to Z, and then return it. So it's just a way to like make a wrapper around it. And for what it's worth, we can do different versions of these. We can make one that works on constant strings as well. So for example, in this case, we could make one like this. Something like that. And what that would do is just say, okay, a constant Z string, where we have the string in here, there's the Z or whatever. We know that we can make one of these by getting the count and then having a pointer to the data. Well, here's a pointer to the data, right? Let's just do that. So we know we can get a pointer to the data really easy. What we don't really know is how we would get the count. But remember, if this is a constant, then what we can do there is just say, well, we know the size of it. The size of it is just going to be however long it is, including the null terminator. So if we just subtract the null terminator away, that would give us a constant, right? So what we can do in this case is say, well, all right, we can wrap this guy, which is fine, and then these guys can be constants, and they don't even need to spend the time to do the string length. They'll just know, right? And that should work, right? What is this complaining about? Connect string to U64. That is true. That's these parts here. I'm going to go ahead and do that this way. This would probably not work as well because the compiler's not going to want to do that assignment in earlier versions of C. It probably will work in this one. Source file, base name. This is not parsed to be a base name. So we should probably do that. So this shouldn't really be done here. The reason for this is so modern versions of C allow you to do the brackets as an assignment. Older versions don't. So in order to maintain some more compatibility with older compilers, I'll just actually call wrap Z in that case. And again, that's just as a courtesy to people using older compilers. 2012 would not have compiled that. I don't know if 2013 would. Might have, but it might not have as well. So anyway, this is not a base name here, so I don't remember if we actually had anything that did that parsing. I don't think we actually did. I think it was just baked into some routines. We could make something that parsed it. But you can see here, this will give us the default annotations that we wanted, and we're going to leave all the rest of this blank because we don't know any of it, right? We don't know any of the other information. These are not probably relevant. I mean, we could set them to the information that comes from source file base, the HHA, but it's just probably not useful. Okay. So what we want to do now is proceed through the process of loading an old v0 HHA file, and so that we can write it. And we also, I think, want to make something that will dump us, give us a quick dump of the contents of an HHA, right? And I think we made a thing like an info minus info. So I think we want a similar thing to that, that would, in addition to just printing out the basics of the file, something that would print out all of the asset arrays and stuff like that. So, let's take a quick gander here. Let's go to Handmade data, and let's use HHA edit minus info to look at, test that out. Oh, that's pretty good. Okay, my bad. Test1.hha. So this tells us just that information. Let's print out anything we could find out from the header, right? So let's print out stuff like the tag count, the asset count, right? And we could also remember whether or not it had annotations. By maybe just storing information about that. Like something that we could store. So we could store the tag count, the asset count, and then had annotations, yes or no, right? So then when we load one of these in here, one of these is just not going to have it. So V1s might have it, and we'll set that flag, but these never would have it because they just don't have annotations. So this tells us, all right, there's 13 assets, 25 tags, no annotations. It's version 0, right? And so then what I want to do is just add another one of these here, which would say, all right, let's also have a dump. And the dump would probably print out both of these things. So let's pull this out. Into like print header info. Like so. Maybe I'll also do this. It's called source file name. Right? Yeah, I don't love that. Let's do it this way. So that way we can print out one of these things, right? And get a good groove on there. So then in here, I'm just going to do, hey, let's print header like so. Oops. And then that way, if you do info or dump, you'll get that part first. So there's info, there's dump, and off we go. Now, you may be wondering why I started doing that. Well, if you are familiar with the bonus pack from the Handmade Fund, Those of you who don't know, like if you go to fund here, if you contribute to the Handmade fund, you get a bunch of stuff by me, like old source code from old projects. One of my really old things that I wrote, but that I've still used today, is this program called TabView. It's just it's the smallest piece of code. I mean, it's an 8K executable from 25K of code, right? But it's pretty handy. And so one of the things that you can do with it is view a file that you want to view in a hierarchical fashion. So for example, if I do this and overwrite that test.out file, for example, or maybe I can do that. If I was to look at test1.dump in TabView, you get a little list that you can, kind of collapse and stuff, right? Make sense? And if I hit F5, it'll refresh the file. So what I want to do now is just kind of lean on the fact that I have that kind of utility sitting around to just mean that if I print out some of these things in hierarchical order, I can also take advantage of any utility like TabView that can parse things in based on indentation like that, right? And you don't need to use TabView, you could use something else, right? But since I had that lying around, that just seems like a good thing to do. That way I'll make sure the output's compliant with that for easier viewing, right? Okay, so in here, when we go through and take a look at the info, dump, create stuff, and so on, what I want to do here is do like print asset array, like so on, or I don't know, print contents. I want to go ahead and take the contents as well. And print those out. So I'm going to loop over all the assets here, and I'm going to print them all out in so much as possible. I can also do the tags separately, although we'll probably want to print those with the actual data. Well, we can do both. All right, so I'm going to go through the asset indices here. I'm going to actually skip 0 because we know that 0 is not a valid asset. So in here we've got our assets. I'm going to print a particular asset. So this is asset, number whatever the number is. And then we want to see, we've got information like the source file base name and the sprite sheet X and Y and that sort of stuff. That's all we've really got here. So I'm going to use that as the information. I'm going to use that sort of as like the name of the asset. And then we'll go from there, right? So I'm going to say, let's print the string. That's the source it came from. And then let's print the sprite sheet X and Y that it came from. That'll be just kind of our way of identifying an asset, loosely speaking. So what I need to do here is get the annotation up for it. I'll just call that A for now, or An. Let's call it An. Loaded HHA annotation, AN equals HHA annotations plus asset index. So that's the asset index there. And I can also grab the HHA asset because we'll want to print out some data from that as well. Asset equals HHA assets plus asset index. So now that we have those two, I can say, first of all, all right, here's the asset, oops, it's not good, asset index. And also here's the annotations. I want to know the source file base name, source file base name dot count, and source file base name dot data. And if I recall correctly, this is actually not, because this is a UMM, this is like, you got to do this, unfortunately. Right? Because you need to actually know what this has to be 32 bits if it's going to a U, right? Because we're not printing 64-bit values there. So, I'm sorry, if it's going to a width specifier. I think. Maybe that's not true. Maybe that does take a size T. I don't know what it takes. Let's see what the compiler says. Oh, and we'll see what it does, too. Sprite sheet X, sprite sheet Y. Because I don't know. Yeah, I don't know what it expects for that. That's a good question. We'll find out. Just put an F0 in here. Okay, so it is an int. Well, I guess technically it wants literally an int. So we'll give it literally an int. So that's how that printout would work. And now let's try to make that actually happen. So when we read in one of these files, you can see us kind of, sort of, maybe a little bit reading in the assets here, like so. The problem that we have is this is actually not correct anymore because these are HH asset v0s that they're coming from. So in here, where we load them, the source assets, it's actually an asset v0, not an asset HHA regular, and so we need to upconvert, right? So when we actually load this here and we say this right here, this line should fail now. It should say like, hey, that's not going to cut it. And so what we need to do now is actually assign the individual elements of the HHA asset in a way that will actually work, right? So now let's do that. It's harder than you might think. Some of it's pretty straightforward, but it's harder than you might think, right? So we'll see what we'll do the easy ones first. HHA asset 0 source asset equals the source asset. Okay. So we've got the dest asset data offset, and we've got the dest asset data size, and the dest asset first tag index, the dest asset one pass last tag index, and the dest asset type. And then we have to do like the bitmap part, or the sound part, or the font part, right? So we got to do something. All right, so the first thing I'm going to do is say that dest asset equals null asset to clear anything that we don't assign. I'm then going to take the parts we actually do know. So for example, the source asset has the correct offset in it. So that's good. And I feel like the tags... So we are not going to add any tags anymore. We were going to, but we're not going to anymore. So the tags will be correct as well. And so the things we don't know are the data size and the type. And then here we need to do a check based on the type. We need to do one of these. So we need to do a switch on the data type here. And this is going to be an invalid default case because we should never hit in a v0 file something that like this that we don't understand. Although I could just print it out. Right? So we could actually do something like that. Source asset index. Now I don't really understand why the source asset index and the dest asset index aren't the same index. Does someone want to explain that to me? Oh, right, because we're doing the unpack. Right, so We could leave them to be that. We could leave them as the same indices, but we don't have to. I feel like you just would, though. I feel like we don't really need to do this, right? Because source asset index is just asset index here. So I'm just going to say this is asset index. We're not adding any asset indices here. So that should just be asset index, right? And that's fine. That all looks good to me. Okay. So in here, what I want to do is say HHA asset bitmap. And all I'm doing here is just assigning the portion of it that I care about. And so depending on which one of this it was, we just take that data, and that data is correct. We don't need to update that data at all, right? We don't have any annotations to speak of, so we just have to give it the default annotation. That's all we've got. And then so the two things we really need to do here is figure out what the data size is going to be, and then figure out what the type is, right? So the data size actually is something that we have to determine sort of like after the fact, right? Like it's something that actually has to be determined like kind of in line, with each of these. So once we actually snap the value, then we can figure out how big the data size is, often, in data land there. And so I think if we take a look at the asset loading, we should be able to figure out how that was going. I feel like that we should have had a thing that said how big it was, like you can kind of see here. Yeah, I mean, unfortunately, it looks like we just kind of winged it, right? Like each time here we have. So, one of the nice things about doing this conversion is going to be we wouldn't have to do this anymore. Like the loader would just know how big it actually was going to be. So that's kind of nice as well. And yeah, I kind of feel like that's a nice, I feel like this stuff could get simplified quite a bit, right? Because you can see this stuff is a little bit annoying, right? It's like, it's fairly complicated to get that size, right? You can see why I don't want that anymore, because even though it's fine to have this happening in the code here, like a simple utility that needs to like update these things shouldn't have to deal with all this crap, right? Like it should just go like, all right, look, I don't know what fonts are, I don't process them, but I just want to move them from one file to another, or I'm updating this file, I'm just going to copy them. You want to not get that wrong. And if everybody had to always do all these computations based on all this stuff, you're totally going to get that wrong, sometimes, right? So I feel like we really want that part to be more sensible, right? So I like the fact that we're going to be pulling that out. So, yeah, anyway, like basing this on what we've got here, all this stuff seems pretty straightforward. So I'm going to go ahead and just do it rote here, and then we may merge these into a place where we could keep it consolidated in a single file that gives us the information that we're talking about here, right? All right, so if we said data size for the bitmap, I'm going to actually go ahead and say HHA bitmap equals source asset bitmap. So that's the data size of the bitmap. The sound, I'm going to do the same thing. And then in here, we can just say, star sound. And then the data size for the sound is handled similarly, right? It's like, hey, whatever the sample size is, which is always that. Apparently, we don't have multiple sample sizes. And then we've got like a sample count. And a channel count. So that's how many of those we're going to have in there. So that's all fine. Then we've got the data asset font part of things. Oops, fount, apparently. And this, again, we got to do that computation of. It's nasty, right? It's kind of ridiculous. This is it. It's actually this here, the 2 computations worth. So we've got the font glyph count squared for the horizontal advanced table. We've got the glyphs themselves, and then we have the Unicode map, and then off we go, right? So it's actually this. And there we go. So you can see why I want to put this in the file now, because now this stuff, if it changes, utilities don't have to know, right? It can get, sort of fussy if it wants to, but it won't affect anyone who doesn't actually have to understand the data. They can just treat it as a blind block and just go from there. So I think this is all good here. Looks pretty reasonable. So we're just down to type, and type is a bit nasty. The reason type is a bit nasty is because in our old our old school, like, here's the stuff that we're storing, you were just supposed to know, right, which ones these were. So what I really need is a cracking table. Like, I need a table that will translate these. And so what I effectively need here is like, hey, yeah, let's find out what the HHA asset type is. I could put it in here, I suppose. So what's the HHA asset type? So like type from ID v0 or something like that, right? And then what I need to do is say, hey, for all of the stuff that was in here, what was it, right? Like, what actually was it? And so looking through all of these, we've got, well, none was none, right? So this was an HHA asset, none. The bitmaps are all here, right? So this is HHA asset bitmap. Bitmap. Apparently there's no stairwell. Bitmap. And then we've got font, and I believe bitmap again, right? I believe that's what these are saying. Then we've got sounds. Like so. And then we're back to bitmaps. Right? So we've got an array that would translate these for us. Now, we have the opportunity here to do something a little bit fancier if we wanted to, and maybe we want to. So what we could do is say, well, in here where we've got this like asset name and we don't know what the asset name is in this case, we could say, well, we sort of know maybe what the asset name is. If we were to make this more of a compound translator of some kind, we could do this, right? And actually, when we do this up translation, we can actually tag these. Oh, that one's not included. We can actually tag these with what they actually were. And again, you can kind of see why this wasn't a great system, right? In terms of flexibility, future flexibility, which is not what it's designed for. So I have no problem with that, but I'm just saying this is why I wanted to change it, is because, again, you want these, if you're just using it as a backing data store, it's fine. If you're trying to do something that would allow like modding or things like that, you need ways of being more flexible about saying what things are and where they came from. Because that information just makes it a lot easier to munge the files around, right? And interoperate between different versions of things, which once you start to get a lot of that in the mix, you just want support, you want to make it easy, right? And so that's what a lot of this, the difference there is. None of the stuff we had originally was a problem, really, but it just isn't super flexible for doing something other than just shipping the game as it is. So here's a little type from IDV0 translation table. Here's the type. Here's the name. And so then what we can do is we can use this as a table to crack open the sort of secret, otherwise impenetrable asset type field that we get in here, right? So we can say like, oh, okay, we now have a type info, and that type info will point to the first one of these, unless the asset type that we received from the file, which has the type ID in it right here, right? If that is valid, so it's less than the size of this thing, so we understand what the type is. If it is, then let's grab it out. And then we basically say, let's take a look at the type IDs, whatever the translator was. Okay? So we go down into the type info, and we can now do better for the default annotation, right? This part here. We can actually make our default annotation have a little more in it than that. So the asset name could actually be something that comes from a buffer here. So what I can do is, make a, well, I guess it doesn't need to come from a buffer. I guess it can just be that string, exactly that string. So whatever this is here, is the name that we're going to use. And furthermore, we now have the type as well. So the type info can give us that information. So now we have a pretty fully featured, I think, import for that. And now we just have to go through and debug it. Looking through here, what are we doing here? One past last asset index. That's supposed to be last tag index. That is also supposed to be that. What else we got? Okay. This is string, right? So this has to do a wrap z. And off we go. Okay, so now we got to debug this. Like, we don't know if it's going to work. I did the dump, but we don't know if it'll actually do anything. Here's what the dump actually came up with. Here's each of the things that was in the file, right? And so maybe it loaded correctly, maybe it didn't load correctly. I have no idea. The only way we can really find out here is let's go ahead and start expanding on these. So make our dump print out the information that's in them and see if they're accurate, right? So in here we've got our print stuff. Let's expand on it. First of all, let's print out the tags. Tags, actually, we also will want a cracking table for. Those are these values right here. So we'll go ahead and make a little cracking table for those. This just needs a name. And again, you can see why metaprogramming is so useful. This is the kind of thing a programmer should never have to do. It's obvious that these are the same thing and the language should support them. C++ doesn't. I mean, I won't belabor the point. I've said so many things about the C++ Standards Committee and how bad they are at everything. Just reference that. This is just obvious stuff that every programming language should have had since like 1980. And how it doesn't, I don't know. But it doesn't, so here we are typing stuff manually still. Even the most basic metaprogramming features would solve that for you, right? So anyway, we want to get the tag name out. And so that we can print that, let's just print out the tags real quickly here. That's really easy for us to do. We'll just say tag index, like so. Load out the tag. And then I will print it out. And so all we've got here is effectively the tag index, the name of the tag, and I guess we don't need a string printer for that because we're actually only getting it from that array. So the tag name and then the tag value itself. Now, we don't want to just print out the tag name directly. What we want to do is first test to make sure that it's valid, because again, remember, these files could get corrupted or someone could write one wrong, and we don't want to just crash on them and have them not know. So we should at least say, look, if the tag ID is less than the array count of that array we've got, then we'll do it, right? But only then. So we'll say car tag name equals unknown. And then we'll just say, okay, assuming you could get it, the tag name equals the one that's referenced by this. Right? Okay, so now if I run this again, there we go. What we should be able to see here is, okay, not particularly good there. Those are all unknown. Good. Yeah, no, totally good. Absolutely what I wanted. Fantastic. Do we just not load tags? Oh, we just don't load tags. So really, we just need to copy the tags here. So let's just do that. These are always the same at the moment, so the tags are just the tags. We don't need to do anything to them. We might in the future if we expand what a tag is or how it works, but at the moment we wouldn't have to do that. So let's see here. Here's a bunch of tags. Here's some stuff that doesn't look right. There's 25 tags, and we don't know what any of these are. Those all seem good. Those don't. Ah. That's because we were going to expand the number of tags, and we're not anymore, so that goes away. Now we're good. Okay, So now we got our tags, we've got our assets. Now let's go see if our assets are correct. Also, we can try a different file. And see how that works. This claims it has no tags. Can that really be true? Maybe it is true. Don't remember well enough. So I don't even remember what's in any of this stuff. It seems kind of not possible, but maybe it is that there's no tags. Let's try intro art. I mean, it looks like we're working properly, so maybe those just don't have any tags in them because they just weren't differentiated in any particular way. They were just like, here, here's a rock. It's got no tags. It's just a rock. You know? All right. Well, that's fine with me. What is structured art.bitmap? Oh, lovely. So I'm just going to go ahead and expand on this, and I'm going to make it print out a bunch more stuff, right? So that we can have a better picture of what's going on. And then I think we're more or less done with the reading. We just need the writing version, right? Which shouldn't be too complicated because most of the hard work we already did, like figuring out the sizes of stuff. So now it's just like a copy. It's just like grab and copy. So that's kind of nice, right? All right, so coming through here, what we want to do now is expand on the asset information that we have. So what I would like to do is take a look at file formats there, and I'd like to go through the file format and print out everything that we have, right? So I want to print out all of this stuff, right? So I want to print out all of that, and then I want to do a switch on the type. And then for each one of these things, depending on which one it is, I want to print out the rest of it, right? So I want to do like, I want to print out those. If it's a sound, I want to print out those. And if it's a font, I want to print out these. And then for each individual asset, I will print these common ones first so that we just know what those are. And I'll print the tag array separately, like so it's like, hey, here's the tags that go with it. So in here, you know, it's just like whatever the asset type was, that's what we're going for here. And if it's some other kind, we just don't print out any extra data. Like if we don't know the type, we just don't print out the information, right? And what I can do here too is I can also say like, maybe do it like this. So if it doesn't know the type, we'll just say like, hey man, it's this type. I don't know how to print that out, but everybody else can print out the actual like thing that it is. Right? And so then, oops. There's just not enough data here to really worry about making it be indented, I don't think. So what I'll probably do is I'll just consolidate this and say it's like just do that. And then I'll just print out the hotspot. Or maybe I'll just say alignment. Right, so something pretty simple like this. I think that's all we really need to do there. And so I'll just do an HHA bitmap here just to make it easier to print it out. Same with the sound. This can be the same, and then it's got a chain mode, so it can be like whatever the sample count was and the channel count. And then the chain value we can switch on and see if we know what it is. And if we don't know what it is, then we just won't. So we have inside file formats, we've got the various chain values somewhere in here. Here they are. I don't really remember if there's anything. No, there isn't. So the chain value, I think, just means move to the next asset index automatically. So I'm pretty sure that that's all that is, right? So I think what I'll do is, let's just do it this way. Let's crack the value first. So let's say, okay, mode equals unknown. And then we'll just say mode equals blah, mode equals looped, mode equals chained, right? And then we'll just say like that, so that we can say here's the mode of that sound. Font data, yeah. I guess we'll just print it out. Something like this. So we'd have these two pieces of information. And then we'd have like sent. I don't know what external letting was. I assume that's just like, hey, this is how much you would go total from line to line. But I don't know, maybe it's the part in addition to the ascender and descender height. I don't remember what we encoded that as. So now we're printing out all of that information, which is nice. And now let's just also add to the beginning of every font here something which tells us the like basic layout of the asset itself. So, wait. So this actually needs to be 1, 2, 3, 4. When I do a lot of coding that does massive stumps like this, I make a little system that automatically handles the tabbing. I'm not going to do that here, but if you spend a lot of time doing stuff like this, you want to do it because otherwise it ends up going pretty bananas on you, as you might imagine. So we need a way to print out a 64-bit value here. I never remember the stupid way that that actually works. It's something like that. I just cannot remember. So we're going to have to look that one up. Sorry about that. We'll do that. Go. So we want to set the tags here. And then deal with the type. So I would also like to actually print out the tags. And so in here, when I actually go to do it, I would like to be able to do a one of these. But what you'll notice is I already excuse me. I already implemented this code down here. So what I really want to do is change this to be so that the part that I actually care about can be reused, so I don't have to do it again, right? So what I'd like to do is make this part here where we actually print out the tag information. I'd like that to work, so like I don't have to do it twice, if that makes sense. So I want this to effectively be a thing where it's like print tag, and I just pass the tag, and it just does that, right? So if I go ahead and take that out, I can make that function here. And this will print out the tag information for me. So then I can do that here, and I can do that here, right? So I can say, here's that tag, and rather than implementing this again, I will just do this. Oops. So to look up that tag, I just need the tags array plus the tag index, and off we go. We should probably put in some things to check the bounds on the tag lookup there. So, you know, maybe we change this a little bit. We'll do that in 1 second. Well, you know what? No, we'll do it now. So we want to check to see whether the tag index is inside the bounds, and if it is, then we'll print it, right? If it's not, then we just want to print like some bad error, like no bad, stop, please do not do that. Everything is horrible, right? So here we can just say like, all right, go ahead and print that tag index. And over here, we'll say, go ahead and print that tag index. And then you can do your bounds checking so that we don't end up in La La Land, right? We could do the same thing up here, right? If we wanted to, we could check to make sure these are not out of bounds. So we could say like, look, if asset index is greater than or equal to HHA asset count, then, oh, sorry, less than, then do this for the thing. Otherwise, definitely don't do that because it's just garbage, right? Yeah. So assuming that worked, then off we would go, put the type info name in there, that's good. And so in here, we just need to say, this is an error. And again, that just adds a little bit of error checking in case someone makes a bad HHA file somehow. I don't think it's ever going to matter, but so let's go ahead and try this again. We do the dump. We reload that. So there's our tags. They look right again, which is good. Here's our assets. And now we should be able to look in here and see a little bit more. It's like, here's the bytes. There's the offset. We've got some tags. It says there's 47 tag. I think we might have flipped those. I think I probably flipped those. Yeah, it should be the other way around. So we'll fix that in a second. There's the two tags in question. Here's the type. It's a bitmap of that size. And here's the alignment. And that all looks pretty good, right? So that looks pretty good. So let me just go fix that typo there for the tag printout. So in here where we say u at u, it's actually that's the count first. There's the count, and there's the first. Otherwise, that looks pretty good. So looks like we're loading these pretty well, right? So assuming that we're loading them well means that at that point we can probably just start to write them. We'll do that tomorrow, and then we'll be done with that. We should do a reader for V1 HHAs as well. That'll be a lot easier because it won't actually require us to do anything. It can just load directly. The only thing we'll have to change is the annotations. We'll have to actually get lofted up, so we'll have to have an annotation like reader in there. But other than that, we're fine. So now we should be able to dump any one of these and see the actual data, like test fonts, for example, we should be able to take a look at. So if I do a dump on that, let me load that up here. So here's all of our assets, just bitmaps, right? If there's no tags, we should probably just skip the tag fields. Maybe like if we're printing this out just to make it a little bit easier to read. If there's no errors and we just don't think there's any tags, maybe we can just say, look, the tag count is this. If the tag count is valid, then we print out the tag array. If it's not, then we just don't print it because we don't need to see a tag array that isn't there, right? So then we reload this and we get all of these have no tags now, right? They're just like, here's the bitmap data, and it's fine. So that's all good. And then there should be an actual asset here that is a font or whatever, right? I think that's all good. The only weird part is, and that looks good, is maybe this should be like the font thing should be up in here, maybe, kind of, probably, possibly. So I almost want to say, like, we kind of want to crack that name out early, like this, like, thing here. Not sure the best way to really do that. Like, I mean, I could just do this thing twice. I don't know. It's good enough for now. All right, I'll go ahead and go to the Q&A here. But I think that's pretty good. It seems like the file format's pretty reasonable now, and this gets us our import. Like, so now we can use our old files if we want to, which I think is good. I would like to know about these. Am I actually doing these properly? Oh, we're not printing out the annotations. I take it back. I'm not going to the Q&A yet. Let me just put in, I wanted to make those annotations come out as well. So I take it back. We want to print this stuff out as well. So in here where we get the annotations, after we print out the asset, I want to go ahead and do like the asset name. So the asset name we could actually put on here as well. We could put that right here if we have one, you know? So that would be cool. And then the other pieces of asset information I should probably put in there as well. So if I do this on a file that, well, even these would have it, right? Because everyone should have it now. So if I look at them, right, you can see what they are. They're asset font glyph, right? And asset font. So, okay, and I'm trying to think if there's, what's the other annotation data here that we want to put? So we got the sprite sheet X and Y. So description and author and stuff, right? So let's just print those out. So if an asset description dot count, if an author dot count, if well, we can just do this, where it's like it's from this source file. And in fact, I guess we don't really need to put that up here. Like maybe that could just be part of like a from line. So we would just say like, okay, it's from this file at this sprite information. The date was that, the checksum was that. just so we can see that date as well. So source file date, source file checksum. And again, I don't remember if %LLU is actually the right thing. We should look that up. Somebody remind me in a second, since we're going to do Q&A. Somebody remind me to look that up. Because I don't remember. And one thing I'd sort of mention as a meta comment, again, a meta comment on metaprogramming. So you'll notice like almost everything I typed in today was just busy work that the compiler could have done for me. If, again, if C++ had ever added anything good to the language, it wouldn't have had to happen, right? It's all rote stuff. You could have written a little routine that just reads the structs and it would just print, right? And that could just, I mean, like every other language has that, right? Like you can, if you just want to, in JavaScript, if you just want to print out the contents of a thing, you can write a little routine that does that. And there's a built-in one that will just do it for you if you don't care, right? But you could write one yourself really easily too, right? So you can, it's really, because you can access the type information. And that is like, the fact that C++ doesn't have that is nuts. It's been 30 plus years and they still don't have it is crazy. I know they're working on one now, but now is not the time. The time was like 1984 was when you should have been working on that, right? Like the time has passed for that to be considered an acceptable thing to not have in your language. The time passed about 20 years ago. Yeah, so this looks good here. All right, so I think we're good here. All right, to the Q&A. Martin says that static assert is a C++ 11 feature and is supported by MSVC 13. So that's probably okay then. If it really is supported by 2013, that's probably fine. Because I think we use the here docs, which are that, if that makes sense. So I'd be okay with that. If we wanted to do it that way, let's see if this works okay. We should be able to do it either way. Oops. So I don't really need a message, but we can put one in anyway. So we could say, look, the message is just the expression. So that would replace the static assert with the C++ 11 way. And if I then changed one of the things in file format, in theory, it should complain, right? So same test. Right. So that's fine. I'm down with that. We could be fancier and say, right? And then it would print that out as the message, right? So maybe that's a little too cheeky. Maybe we would just say that, right? So, and I'm fine with that, and we can flip it back if we need to. Jim Zeros, he just heard, do you have a trick for getting a number for file to use in the struct name, assuming you don't have a trick for using that in the struct name? How would you do that? Well, you could... You could what? I mean, you probably can't turn the address of it into something. So. Yeah, no, I don't. I don't have a way to do that. Oh, whoops. I have a typo. Someone says I have a typo. Let's look at that. Here we go. Thank you. In an earlier episode of Handmade here on day 160, you answered a question regarding you had planned splitting Handmade here into two parts. First running the engine, second running the game, and there was a clear divide. Do you still feel you're moving towards that goal, or do you feel it's better when you move to the game code to still work on the engine head features? No, I mean, I think it'll still be pretty clear. I mean, we will always... It's our engine, so we'll always allow ourselves to go fix something if we don't like it. But the goal is at some point, you know, day 500 or something, to just say, all right, everything's good. You know, it's pretty much does what we want. It's pretty close to doing what we want now. There's a few things, like I got to finish up the lighting stuff, and I would like to do a little bit of cleanup on the entity stuff. Like, there's probably some stuff I'd like to do, but there's not. I think we got mostly everything down there. So we should be good. How do you deal with concurrency in C++? Well, I mean, usually you... With concurrency, it's kind of a large topic, and I would rather not go into too step right now because it's not really relevant. We did concurrency related stuff earlier. But the problem I see with concurrency most of the time is that I've never really seen any good ways of dealing with concurrency systemically that aren't slow. A lot of the stuff that I've seen people where they propose, like, here is a system for handling like how you're going to thread this thing, it's just much slower than a version that was actually written customized to only do like the minimal amount of, you know, locked exchanges necessary to implement the actual algorithm. Now, of course, that doesn't mean you always want to write it, because the problem is concurrency is very hard to get right. And you always have bugs in it, and you got to work to get the bugs out of it, and that work may not be work you can afford to do at that time, or so on. So it's difficult in that regard, right? And so I would basically say that the main things you're looking at when you're talking about implementing concurrent things in C++ is dividing things into probably two parts. You know, one where you have a sort of somewhat generic system you made that just calls people back to do work concurrently. We've done that in Handmade Hero. It's how the lighting works. It's how the software renderer worked. And you just assume that that'll be fine for most cases where things are just doing computations that don't interfere. And then you have to have some more special purpose code that you write for data structures who themselves have to be handled concurrently. Because that just ends up being hard to do, and it's usually very sensitive in terms of you can very easily end up with code that runs slower than the single-threaded code if you aren't careful and you just are locking all over the place or doing bad things like that. So, we do a bunch of concurrency in Handmade Hero. Go back and look at those episodes if you're curious about it, but it's not really a silver bullet kind of thing. Why is HHA version 1 still important? Is it only to convert the few existing assets? Yes, and also I just wanted to show how to do it. So, you could imagine a project where you had a lot of stuff encoded in an old file format and now you want to get it out. This is the case. This is how you would do it, right? We don't need to do it because we didn't store our data permanently in that format or anything, so it's not really the end of the world. But it's just, I wanted to show how to do it. How do I feel about the progress of Handmade Server? Really good, actually. We don't have a good thing that shows how many weeks of programming it has been equivalent. But it's not many. It's not even a year of programming yet. And we have just a ton of stuff in there. So I'm pretty happy with it. It feels like a pretty decent engine for what it's designed to do, and I feel like it showed how to do a bunch of stuff. Should I learn C or C++ first? Is there a good advantage in C++ offers? Well, it's a tough question. Really, the answer is it depends on what you're trying to do. So if you're just trying to work on stuff that you wanted to work on and you want to program sensibly, then you can really just learn C and you don't really need C++ for anything. It doesn't have very many good features in it. It's pretty poor language. It's just not a good language. However, if you're trying to get a job programming in games, you need to learn C++ because a lot of people think it's good for some reason, and they poop out C++ all over the code base, and you need to be able to read it and work with it, right? That's just the way it goes. So you need to learn C++ eventually if you're going to get a job in an industry that uses C, because most of them use C++ as well. I would start with C and learn it because you can't use C++ at all without knowing C. C is a prerequisite, so keep things simple. Learn C first, then learn C++ as you go after that. But regrettably, most of the time you probably will have to learn a fair bit of C++, even though most of it is garbage. And that's just because of the industry. Given that static assert is a language feature and you can't really implement it yourself, why not just use it? Because it doesn't work on past compilers. It was very recently added. Remember to look up printf stuff? Yes, I should do that. Let's see here. Hopefully, did Stack Overflow get it right? Did they get it right? Well, they did what we did. So let's say that that's right. I don't know. I should look it up for real. Stack Overflow's wrong all the time. Let's see if I can get an actual documentation from yeah. Long Billion, I know we haven't done much with in-game text in this series yet, but could the ASCII system be used as it is for storing story text, tagged with language tag for translation, and other relevant data tags? Maybe we would want custom tags for storing long codes, or do you think it better to make a different system suited for this purpose? Also, tab view is looking cool. All it needs now is the iconic Handmade Hero dark theme. Good point. I don't see why you couldn't. I mean, you'd probably want to make a new type called HHA_text and store that as an asset type. And then you could tag it with, yeah, like, you know, information necessary to know when it should be used. Seems fine to me. We could do that. I don't know what we want to do with that really going forward, but we definitely could do that. One past last asset index is not an asset count. That's why we don't do that. We wanted to store one past the last one, not a count. If we do, we store count. We do call it count when we store that. Maybe you could add the line to the message, or did it print the line numbers? It prints the line numbers for you. The compiler gives you an actual error here that you can just jump to, so we don't need to print the line number. Does the CT assert fail if you have two asserts in two files on the same line? Yes. It will. That's why people often do a thing where you pass in a name here, but you can usually get away without it because there's just not that many of them. I'm interested in knowing how downloading a patch or DLC is getting installed and changes existing code works. Would that be covered at the end? Possibly. In our particular case, you can add stuff to the game by just dropping in a new HHA, so we kind of already covered how that works. So I guess what I would say is the patch part where you patch an executable is probably to ship a new executable because our executables are tiny. How did you recompile reload a DLL when load library seems to keep a lock on the file? Well, you can just unload the library, right? You just do free library. But yeah, you can copy the DLL or just change the DLL name. Why not use -1 instead of 0 as array length to get a harder error? You could, yeah, you could, but the error seemed pretty hard at the end anyway, so it seemed okay. But yeah, we could do like that. It seems like a good idea. Yeah. Long is not the same as N64 T-type. It is 64-bit, but GCC Clang will still complain that LLU does not match uint64T. The proper way is to include int-types.h, which provides compiler-specific PRIU64 string literal as a define. So you need to do printf %PRIU64, comma. Are you kidding me? Who did that and why, Martins? Martins, why would they do that? That's horrible. Does the preprocessor parse before include directive and then resolve the line after the include is parsed? No. It's the line. Well, okay, so I should specify __line __ technically expands to the line counter that is set at that stage of preprocessing. It doesn't even have to be related to the file because you can actually change it. So let's suppose, for example, we did like or like this. How can I make this actually show me something? Trying to think of how I can show the line number in an error message cleanly, and I'm not thinking about it. I don't think you can't do this, can you? Yeah, I don't think you could. That's too bad. Probably can't do this either. I apologize for the incredibly annoying. Actually, it should only need to be able to do this. I probably can't do this either, can I? All right. So let's just do this. Here's an error. Right? And you can see that it says it's on handmade platform.h 278, right? So really what's happening there is when the preprocessor starts preprocessing a file, it sets the line counter and the file to be that file's name and the first line. But that can actually be changed at any time. So for example, I can just do this and say what I want the line number and file name to be. Now, I don't remember which order they go in because you hardly ever type this. It's, which order is it? Digit sequence file name. Okay. So if I want to, I can say this is now line 56. And now it says the error is on line 56, which, hey, it's not, but it's not something that the compiler maintains as important. It just says, hey, you told me that that was the line, so that's what I printed out, right? Similarly, I can say, like, you know, oh, it's actually on real fruit flavor.h, and now that's where it thinks the error is, right? So the real answer is that file and line are actually just conventions that the compiler sets normally to the beginning, the name of the file and the line counter at such a time when it goes to process the file, but you can set it to whatever you want later, right? Use at your peril. The good news is that starting with C99 printf supports U modifier for size t, so ZU or ZX would work. Doing the Z modifier for size t? I'm confused. So are you saying that if I wanted to, I could I do this? Could I do this now and be okay? Like, would that work? Okay, so that works. That's cool. I think that's good, Martins. Will that be okay across on GCC? I'm always afraid on GCC because I know that a lot of things break over there. Have you ever changed the line number or file name in that way in an actual project? Yes, actually. If you do metaprogramming, you probably will. And the reason is because you generate a C file from a C file, and you will want to set the error to go to the original C file, potentially, right? Okay, Martin, Z modifier. Yeah. Okay. So I was just asking, can you just use ZU then? Is that just safe now? Is that just the right way to go from, 11x forwards, or not really? It will only work for a size T type, not a uint64T type. Okay, but that's okay. It's at least compact, right? So, I'm okay with that. Would that be acceptable on GCC? Yeah, so hopefully that's okay. All right, I'm going to go ahead and close it down. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so that you can play around with it yourself. Maybe you would like to try your hand at writing out the HHA files tomorrow before I do, and you could try that tonight, in fact. We also have some other stuff you can, I point out today on the stream, the Handmade Fund is the place you can support community projects, and it comes with some fun stuff from me as well, like that tab utility and the source code to it, as well as a bunch of other stuff. We also have a watch page you can use to watch the series that also has an annotated episode guide on it, so if you want to catch up with old episodes of the series, you can search it. It's pretty awesome, and jump right to the places you want to go, so check out that watch page as well. And if you want to see any of the other products we're working on at Molly Rocket, just click on the Handmade Hero head. It will get you to all of our pages nice and quickly. That's about it for today. I'll be back here tomorrow when I'll just do the HHA writing. And I think that'll be about it for our HHA maintenance. Hopefully from then on we kind of have nice smooth sailing for manipulating our asset files and playing with them however we want to, which is good. We could even write a merge utility or other stuff like that really quickly, I think, now. That's about it. Hope to talk to y'all tomorrow about that. Till then, have fun programming. I'll see everyone on the internet. Take it easy, everybody.